let us look at another example of an integration where we perform a line integration and we use Green's theorem. All right. Now, the integral, let's call it I, is equal to the integral along a curve around a closed path of x, y. Dx means this is the horizontal component of the vector plus 2x minus y. dy meaning is the vertical component of the vector, where this is the equation of each vector in a vector field, and the region where this will take place is y equal x squared and y is equal to square root of x. All right, so that's the region where that will take place. Now the thing is, what would that look like? I have plotted it already using GeoGebra. All right, now here the black curve, let me just see the label. The black curve is f of x is x squared, y equals x squared, and the red curve here is x to the 0.5, which is x to the half, same as square root of x. All right, so you can see they go from 0 to 1. Now, of course, in the exam you might not have anything to plot it, but here, if you have an idea what the curves look like, you know that y equals x squared, part of it goes like this, and then y equals square root of x, part of it goes like this, right? And of course, you'll have to figure out exactly where they start, which is 0, 0, because where you make x squared be equal to square root of x, if you square both sides, you get x to the fourth equals square root of x squared, which is just x. So x to the fourth minus x is equal to 0. And then if you factor x outside, you get x cubed minus 1 equals 0. Now, where are they equal? Well, certainly, if you make x 0, then you'd have 0 multiplied by 0 minus 1, which is 0 times negative 1, which is 0. So both of them are equal at 0, right here. But what's the other point where they are equal? Well, if you make this one 0 and you say x times 0, how do you make x cubed minus 1 0? X cubed minus 1 equal, because one of them must be 0, or maybe both are 0 to make the answer 0. If x, what's going on here now? What's happening? Stuck. You're telling me that this thing got stuck. What's going on here? No, man. Something's wrong. thing got stuck. For some reason or another, this thing stuck. Why? My gosh. No, man. Oh my gosh. Oh my gosh. What's going on here? What's going on? Oh, having some technical problems here. Technical issues. Oh, I just plugged out this thing and plugged it in back a while ago. Alright. Beg your pardon for that. I was having some technical issues because the computer got stuck. I just figured out what happened. Alright, so where were we now? We were saying that if we make x cubed minus 1 equals 0, then x cubed is equal to 1. So in that case, 1 cubed is 1, so x equals 1. So both of them are equal where x is 0 and x equals 1. Alright? Now, you can see this is 1, 1. So basically, we're integrating what I call x squared along here, and then what I call the square root of x back to here. Alright? So you might, alright, so here, let's say this is y equals square root of x. Alright, let's just label them. And this is y equals x squared. So let's see how this goes now. Let's erase some of what we have here. Now the thing is, what I want to do here is use line integration first, because we want to make sure that the Green's theorem is correct. What we get in the Green's theorem is correct. So, and the thing is, in any case, you need to practice your line integration. So, let's do it by line integration. Although generally line integration requires more work and takes longer to work out than Green's theorem. Green's theorem is more of a shortcut, but let's use line integration now. Now, you integrate along y equals x squared. If you go along y equals x squared, what would happen? Now, let's use a parameter, right? Because the thing is, when I have a problem with this function, and remember, by the way, all of this is integrated, even though I didn't put the brackets there. It's not just xy dx is integrated and then you add 2x minus y dy later on. All of it is integrated. Now, you have x and y mixed up together and you have dx and dy mixed up together. You could manipulate this thing so that you have x alone with dx or y alone with dy. But let's use a parameter. Let x is equal to the parameter t. So in this case, what is y? Y equals x squared, so y equals t squared. So you'll have everything as t and dt, alright? I need to change dx to dt. So if x is equal to t, then what you have is dx by dt would be equal to what? It is 1. So when you transpose these things now, you will get dx is equal to 1 times dt. So in this case, dx is dt. Alright? And then, what dy, we want dy. Y is equal to x squared along here. So, dy by dx will be equal to 2x. Now, you transpose to make dy the subject. What you're going to have is dy is 2x dx. And then, oh, yeah, that's it. Dy is 2x dx. So, rewrite this whole thing. The formula for the vector field. Alright, so here, in this case, what we're doing is integrating from 0 to 1. So we have the integral from 0 to 1 of what now? X times y. But that becomes t times t squared dx. Dx is dt. dt. Alright, what happened after that? Plus 2x minus y. So you have 2 times x, which is t, minus y, which is t squared, and then dy. But what is dy? Oh, what did I do here? I need to go back to this thing here. Let me redo this part, because I accidentally wrote dx instead of dt. If you have y equals t squared, then dy by dt, what it should be, dy by dt is 2t. So when you transpose, multiply both sides by dt, you get dy is equal to 2t dt. Alright? So dy is 2t dt. So, we are consistent now. We don't have two letters mixed up, and d one letter and the other letter, d the other letter mixed up together. We have all t's and dt's. So, here now, what we have, let's simplify this, is the integral from 0 to 1 of, then t cubed dt plus, let's open the bracket here. This is going to be what now? 2t times 2t, and that's going to be 4t squared minus 2t times t squared will be 2t cubed. Alright, all that at dt. We could factor out the dt, you know. Let's factor out the dt. You have the integral from 0 to 1 of t cubed plus 4t squared minus 2t cubed dt. Alright, nice. All of this. So, here, we could put the t cubes together, you know. Right? And then what we would have is the integral from 0 to 1 of 4t squared minus t cubed dt. You see that? You see what happened there? Alright, so let us integrate now. This will give us 4t cubed over 3 minus 2 to the 4th over 4 from 0 to 1. See that? So when we do that, what we'll have is 4 t cubed mean times 1 cubed over 3 minus 1 to the 4th over 4 minus, then you put in the lower boundary, 4 by 0 cubed over 3 minus 0 to the 4 over 4. Now you very well know that this would be 0 minus 0, which is 0. So you don't have to worry about this anymore. And then this part would be what? 1 cube is 1. 4 over 3 minus a quarter. Alright? 4/3 minus a quarter. Let's use common denominators. 4 over 3 minus 1 over 4. If you multiply this by 4 and the top by 4, you get 4. 16 over 3 fourths 12. So this would be 16 over 12 minus, you want something over 12 here too, so multiply both the top and bottom by 3. The bottom would be 4 3s 12 and 1 3 3, so it's 3 over 12. So this would be 3/12. So what happened? 16 minus 3 is 13, so this is 13 over 12. Alright, so when you integrate along, what was it again? Along y equal x squared. So along y equal x squared, what you get is 13 over 12. Nice. Now let's go along y equals square root of x. Along y equals square root of x. Since we're going to do some differentiation, we just write it as let's write it as y equal x to the half. All right. Now we want to write as using parameters again. By standard you make x equal the parameter, and then after that, just like how you have y equals something happen to x, you're going to have y equals something happen to the parameter. So let x equal t, y equal t to the half. See that? Okay. So we have both x and y written as t, but we need to change the dx to dt and the dy to dt. So what would dx be? If x is equal to t, then you're going to say dx by dt. You differentiate x with respect to t and you get 1. So dx is equal to dt. See that? Now let's look at y. Y equal t to the half. So therefore dy by dt would be equal to half t to the half minus 1. Half minus 1 is negative half. So can rewrite this as to the negative half. Alright. So that's dy by dt. Let's bring it up here. Alright. Let's not leave out the negative, the 1 over. Alright, so that's what we have. Now, let's rewrite the equation of the vector field. We're integrating from 0 to 1 of, because it's 0 to 1, you know, because x is from 0 to 1 and x is t, so t must be from 0 to 1 too. Integral from 0 to 1 of xy dx. So what we have is the integral from 0 to 1 of, it says x, y dx, but we want to change it to t. X is t, so get rid of this and put t there. Y is t to the half, so get rid of this and put t to the half. Dx is dt, so get rid of the x here and put t. Alright, plus, what's going to happen out here now? 2x minus y dy. So this will be 2x minus y dy. But now, x is t. So we change this to t minus y. y is t to the half. So we change the y to t to the half minus dy. What was dy again? Oh, I should put the dt up here. So when you transpose for dy, you get dy is equal to half t to the negative half dt. So dy is half t to the negative half dt. Alright? Now, here, we simplify and so on and so forth. Alright? So this becomes integral from 0 to 1 of t to the 1 by t to the half means t to the 1.5, which is 2 1s to 1 1 3. T to the 3 over 2. This is, you could say it is t to the 3 halves. Alright? dt. Okay, now let's open the bracket plus, and you multiply this by this. You get half by 2 is 1. T is t to the 1 plus t to the negative half, mean 1 minus half. So this will become t to the half. You see that? So it's t to the power of a half. Same thing as the square root of t, right? Then negative t to the half times this is minus is going to get half t to the, now when you add these things, right, you're going to get t to the half minus a half. But half minus a half is what? Well, when you say half minus half is 0, so it's t to the 0. Right? So it is t to the 0 that you have there. Alright. And you have the dt. Well, dt will go on all of them because I opened the bracket. Alright, so let me see what else is happening here. Could factor out the dt too, you know. Make it look a bit simpler. 0 to 1 of t to the 3 over 2 plus t to the half minus half dt. See that? Just factor out the dt there. Okay, so ready to integrate now. Don't want to run out of scrolling space too early, so let me go across. This is t to the 3 over 2 plus 1 over 3 over 2 plus 1 plus t to the half plus 1 over half plus 1. You have to remember your power rule when integrating. Plus half t to the, remember this was t to the 0, so this is now t to the 0 plus 1 over 0 plus 1. Although I expect you to remember that. All of that. Well, you're going from 0 to 1, right? From 0 to 1. So this simplifies to what? What would happen here? 3 over 2. 3 over 2 plus 1 over 1 is same as 3 over 2 plus 2 over 2. 3 and 2, 5. So it's t to the 5 over 2 divided by 5 over 2. Alright? So that's what you have. Plus half plus 1. Same as 1.5, it is 3 over 2. So it's t to the 3 halves divided by 3 halves plus, well, this would just be half t. We're going from 0 to 1. Alright? Make sure you're following, you know. Right, you can pause the video at some point and work it out yourself. Well, you should work it out yourself. Oh, by the way, you should have made an attempt at working it out yourself before. But even if you didn't do it after you watch the video, you should try again to work it out by yourself. Okay, so when you substitute the upper boundary 1, this will be 1 to the power of 5 over 2, which is just 1, divided by 5 over 2, plus, and then this is 1 to the 3 over 2, which is just 1, divided by 3 over 2, plus, this would be 1, half by 1 is just half, minus, and of course, we're going to have 0 over 5 over 2 plus 0. 0 to the 5 over 2, which is 0, 0 to the 3 over 2, which is 0 over 3 over 2, plus half by 0. So all of this will amount to 0. That's gone. Now, 1 over 5 over 2. Same as 2/5. Alright? Oh, by the way, my mistake. Hold on. I just realized it. When we go along y equal x squared, we went from 0 to 1. But when we go y equal square root of x, we're going back this way. So we go from 1 to 0. So this should be 1 to 0. We could keep it as 0 to 1 and put a negative sign in front. But I prefer to put it back from 1 to 0. So we're going from 1 to 0, right? This here should be from 1 to 0. This here should really be from 1 to 0, right? It's integral. When you integrate this now, it is the upper boundary that will be 0 and the lower boundary 1. Right. So that's what should have happened. My. Alright, so what it means here is that all of this should have been over on this side. Right? So we put the upper boundary, which is 0. So the integral would be 0 first. That amounts to 0. Minus. And then all of this part here. So this is equal to what now? You have 0 minus it. So you're going to be a negative. Alright, 1 over 5 halves is the same as 5. The same as 2/5, right? Plus 1 over 3 over 2 is the same as 2 over 3 plus half. Okay. So this will be negative what now? Want to work it out? 2/5 plus 2/3 plus half. If we do it as a fraction, 326. Suppose we multiply the bottom of every part by 6 times 6 times 5, 6, 30. No. 5 3 is 15. 15 2 is 30. The LCM of 5, 3, and 2 is what? 15 is 30. Alright. So if we multiply the 5 by 6, we get 30. If we multiply the 3 by 10, we get 30. If you multiply the 2 by 15, we get 30. Okay, so common denominators. We want the same number in the denominators throughout. So we get 30 throughout. So this would be minus. Everything is minus, you know. So we go to something over 30, 5, 6, 30 plus something over 30. 3 10s 30 plus 15 2s 30. Alright. The fact that we multiply the bottom by a number means we must multiply the top by the same number, right? So what we have here is 2 6 12, 2 10s 20, 15 1 15. Okay, so that's what we have there. So it's a negative. Now we're going to have something over 30. What will it be? So what we have here, what happened with the half? Hold on, what happened with the half? We had said minus half before, and I accidentally wrote plus half. Yeah, just realize it. It should be a minus half, not a plus half, right? Or it's a minus t to the half. So when you differentiate, it's minus half, so it's minus half throughout. You see how easy it is to make mistakes when you have these long complicated maths. And remember, this is the line integral, you know, it's not Green's theorem. We're going to do Green's theorem in the next video, which would be more of a shortcut. But you see how the line integral, how much work you have to do. That's why Green's theorem is useful, right? This kind of look like x, it should be half. So that's the use of Green's theorem. Make the work shorter and you're less likely to make mistakes. My. So it should be half here, not plus. Okay, we're back on track. So 12 and 20. 12 plus 20 is going to be 32. 32 minus 15. Or 1 from 3 we get 2. 5, 6, 7, 8, 9, 10, 11, 12, that's 7. And 2 minus 1, 1. So it's negative 17 over 30. Okay, negative 17 over 30. Alright, so we call it I. The integral is going to be this part, 13 over 12, plus the next part. So let's get rid of this. The integral, which we call I, was 13 over 12. 13 over 12 plus, well, it's negative 17 over 30. Alright. So this amounts to 13 over 12 minus 17 over 30. Alright? Now what does that give us? Notice if you multiply 12 by 5 you get 60, so I would be something over 60 minus 13 by 2 is 60, we get something over 60. We must multiply up here by 5 too. 5 3 15, bring down the 5, carry 1 5 1 5 1 1 7. Right, minus, multiply the top by 2, this will be 34. 75 minus 34 is what? This is 1 3 4 5 6 7. So you have 5 3 15. Oh, 6 is 6, not 7. Right. 5 3 is 15, bring down the 5, carry 1, 5 1 5 1 6 over, alright, just double checking, 12 5 60 minus 2 7 14, bring down the 4, carry 1 2 1, so 1 3 34, right? So it's 65 minus 34. 5 minus 4 is 1, 6 minus 3 is 3. So this is 31 over 60. Alright. So the answer we got is 31 over 60. What that means now is that in the next video we're going to do it again by Green's theorem. But I expect it to be a lot shorter than this, and we should get the same 31 over 60. So let me just write it up here. From now the answer 31 over 60. In the next video we'll do it again by Green's theorem.